All right, so this is a lab equipment we are going to use for first two labs. It's designed by our university. It's a logic trainer. Okay. I think most of you are in first year may not have too much background information about the hardware. And this is called a breadboard. Okay. Breadboard is a very useful hardware. We can do fast prototyping. Okay. If you design a circuit, we want to test the circuit in hardware is correct or not. We don't need to use some solder to solder them with each other, and we want to test them temporarily. Is working or not? Okay, just test your circuit. It's called a breadboard, and in the breadboard, here will be power supply. Okay, in power supply, some 5 volt or ground, we can connect them each other, and this line will be interconnected from the back. Okay, which means this one is connected with this pin. You just connect them together, and this one will connect to all the way to here. All these pins holes are connected together, and in the center here, it will be in different way. Okay, so this pinhole interconnect with all these 5 or 6 pinholes from the back. Okay, they connect each other. You can see from here. So they are all connect each other. Also, this one will all connect each other. Okay, so this is the breadboard. And this digital trainer gave us some easy way to show the input and output digital information. Right, so there's power supply, and we have 5 volt power supply and ground power supply connections. All right, let's think about one example to get a more understanding about this hardware. Let's think about we want to do something simple. Let's say we have a NOT gate we just introduced. Okay. NOT gate will do the inversion, digital from 1 to 0, 0 to 1. Okay, so this is input. This is output. Okay. So in this case, think about this one. This is called the pin out diagram for the edge chip. Okay. We have this edge chip, and we have data sheet to show the diagram. So each pin connect to what? Okay. For example, this one has totally 6 NOT gate on the chip. Okay, this one has 6 NOT gates. I think about this case, we only need one. I think about we want to use this NOT gate to do the NOT function. So in this case, this pin need to connect to the input. Okay, and this pin need to connect to the output. Okay, so input we can have on, high or low information. So in this case, what do we do? Look at this one. This yellow box has 8 input switches. So switch go down means 0, switch go up means high or 1, and this particular one is linked to this pin. Okay, what you need to do, you need to use this one called the jumper wire. We have pins here, male to male jumper wire. We just need to plug in this pin into the pinhole. Okay, so we need to do this type of connection and connect to here. Okay, so this first connection, we just grab a wire and from there to there. Okay, so plug in. Later we have some introduction, just show you on the real hardware. So now let's do a little bit quickly. So this one, okay, will be output. So how do we know the output is high or low? We use this logic output monitor to monitor the output information. If LED is on, means it's high. If LED is off, it means it's low. In this case, we need to use another jumper wire. Let's say connect to here. Let's say connect to, if we connect to this pinhole, means this LED will show on or off this for this particular output. Okay, and so keep in mind all the IC chips need power. Okay, if we only connect these two, it will not work. Why it not work? Because all the power IC chips need the power to operate. So in this case, VCC is the power supply. We need to connect to 5 volt in this case. So VCC is this pin. Okay, so any this pinhole we can connect to the 5 volt pin there. Okay. Also, don't forget it's common mistake. Ground need to connect to use this to represent the ground, and ground is this one. We need to use another jumper wire to connect to this particular pinhole. All right, so this is a connection. How do we do? Oscilloscope, when we want to see the information better, we need to use this machine. It's called the oscilloscope, or DSO. This one we can see the digital information, digital waveform information over the time. Okay. In this case, we have 2 channels. We can connect our input to this channel, output to this channel. Then we can see 2 channel information. We can see they are operating in node function or not. So this is the nodes we can control to zoom in or zoom out in time domain. Just change this node. And this one is the y-axis. Okay, we want to see the voltage in this way. Just show you voltage higher or lower using these 2. So one is for X, one is for channel 1, one is for channel 2. They have different color. And to connect them with your hardware, we need this one called BNC to alligator clip. So we need clip our jumper wires to feed our information to the oscilloscope. Okay. All right. Let's have a look at the real hardware now. Can you see the hardware we are going to show? Okay, hope you can see it. Let's try to demonstrate. Okay. All right, so this is the hardware we just introduced. What we need to do, we need to switch on. Okay. And this is the edge chip I already put it there. And we just need to follow whatever we just introduced. This is the edge chip. We need to use the jumper wire to connect the, let's say, this is the first input. Let's switch it to be low. And this is the pinhole related to this digital input. And what we just introduced, we need to connect this to the first input. Okay, if you can see there was small notch here, just make sure we plug in our edge chip to the breadboard in correct orientation. You can see this small node here, to make sure it's in this direction. Okay, our input is ready, and output will be this pin, and output, let's say we want to show on this LED, and this pin is related to this LED. Okay, let's switch on, switch off. It doesn't work. Okay, why it doesn't work? We just introduced. Any IC chip need a power supply. Okay, so this one is 5 volt. Okay, we need to give the power supply to the here. Okay, seems it's already working, but the good practice is we do need the ground as well. So this one is ground to this ground pinhole. Okay, now let's test. So input is low, output is high. Okay, then we toggle it to be high, output is low. Okay, it's basically it's a logic function. Okay, that's good. So this is the input switch to control the input digital information. Now let's think about a clock. If we want to see it over time, and this is the clock function. Okay, we can control the clock frequencies. On the left is 1 Hertz, and here is 10 Hertz, it's 100 Hertz. And this is the pinhole we want to connect to the input. This is the input terminal. Okay, and if we switch over to here, okay, we will see output is flashing. Okay, every 1 second. And also, if we want to see the output, we want to see the input as well to show it on LED. And we need to get to another LED to show the flashing. Okay, basically this is the input digital waveform. This is the output digital waveform. Okay, and you can see they are flashing. So they are flashing in opposite way. We can see they are doing inversion or not function. Okay, this is a 1 second cycle. Now let's think about something interesting. If we push this button, the clock will change the speed to be 10 Hertz and see what happens. Okay, we have some flashing LEDs. If you can see, they still have some not function. Okay, flashing. Okay, you can design your Christmas light, flashing LEDs. And if I make faster, okay, if we make faster, this one seems constant. Why is it constant? Because it's flashing so fast, so we cannot see the changing. Okay, because it's too fast, which means this LED cannot see the details. That's why we do need this machine. Okay, let me see this machine. Okay, let me put it down. This one called the Oscilloscope. This one can see more details over the time diagram. Okay, let's switch it on. It's very powerful equipment. If we want to see the time information and more details, okay, we can use this. All right, as we mentioned just now, we have 2 channels, okay, yellow one and the pink one to represent the 2 channels information. So to connect our digital information from this board to the machine, as we just mentioned, we need this BNC cable. Okay. Okay, we have the clippers and connections. Let's connect this one to the channel 1 first. Okay, channel 1. We have, let's see, we have 2 clippers. The red one will be the signal we want to check. Okay, let's see if we want to check the input signal. We just clip it on. And black one will be the ground terminal. Make sure always we connect the black clippers to ground. Okay. Then I just introduced. Don't forget this one called auto setup. I call it a magic button. So just push the button. The system will adjust the scales automatically and show you the information. Okay, that's good. We can see the input signal is a square wave or clock signal. Okay, from low to high, from high to low. All right, now we want to see the output as well. We need another BNC cable and which connect to second channel. Okay, and again, red one will be the signal we want to check. So this is the output signal we want to check. Okay, click on. And also, don't forget, we do need the ground. Okay, ground is here. All right, and we do have 2 signals. Okay, and automatically they start from different point. Then we need to adjust something. Let's see, this adjust the position for channel 1, channel 2 to match channel 1. Make sure they are starting from same one. Okay, same level, start from same level. Okay, basically you can say input, output, they are operating in inversion or not function. All right, so we can see the details. We cannot see details here because this is too fast, cannot see, but this machine we can see. All right, basically we can see the function. Now let's think about one more step. How about we want to see some more information during the transition period? Use this button. Just zoom in. Okay, zoom in. We can see more details. Okay, keep checking. Zoom in, zoom in. Okay, okay. We can see some overshoots. Okay, we just introduced. For non-ideal digital waveforms, we do have some overshoots. And if zoom in more, okay, you can see it takes time to reach high and takes time to going down. So this transition information, which we can see much more information. And you can see this one means 20 nanoseconds. If you can see, means it's one blocks. Okay, one box means 20 nanoseconds. Means the transition time is roughly 20 nanoseconds. All right, so this is a hardware introduction. Hope you can be clear about this, the hardware and the equipment for our digital labs.